Okay. Okay, ladies and gentlemen, Jake Archibald.
Hello. Okay. We're probably going to start things off pretty lightly. It's the first talk in the morning, so we're going to go for an in-depth look at part of the What WG spec. I'm not very good at introductions, so I'm just kind of going to start. Back in the dial-up days, we were at peace with the internet being this temporary thing, this transactional thing. We'd dial up, we'd log in, we'd check our email, and then we'd get out of there. And that's it. That was our time on the internet for the day. We didn't really care about it anymore. But now we're almost always online. We all carry devices around with us that are pretty much permanently connected to the internet. But because of that almost permanent connectivity, it makes it a really big deal whenever we're not connected. I don't know how many people here have traveled from overseas and are having to roam for data. But if you're data roaming, you know exactly what I'm on about. With data roaming, I'm like a gambling addict. I know that every time I connect, I'm hemorrhaging money, but I can't help it. I need my internet fix. I need to know, it's like there's this party going on that I'm not invited to. And I keep connecting to try and find out what's going on. My phone makes this little sound, this little beeping sound whenever I'm data roaming as a kind of warning. But I don't really need it because I can almost hear the champagne corks popping in the T-Mobile office with every megabyte I eat. You know, they're off buying new cars because I've connected to the internet. I'm kind of disgusted by my own dependency on data. Where I used to work at a company called The Team, one day I needed a dump. And that's okay because they have toilets for this. They have 5 cubicles to choose from. But on this particular occasion, the first 4 were occupied. And that's usually okay because I tend to only need 1 toilet at a time, unless there's extreme circumstances. But I knew from previous experience that the office Wi-Fi only reached the first 4 cubicles. And there's no mobile data in there either. And I thought for a moment and I decided, no, I find this completely unacceptable. And I turned around and I went back to my desk and I waited until later. I've become a person who actually requires an internet connection to take a shit, you know. Well, what can we do to solve this? Well, we can't create data out of nowhere, obviously, but we can make our sites work offline with pre-downloaded data and let users use that data in new ways. So historically, browsers only worked with an internet connection. They've always had a cache, or had a cache for as long as I can remember, but neither the user nor the website has enough control over that cache to create a reliable offline experience. Google weren't happy with this, and they created the local server API as part of Google Gears to solve this. And that let you store bits of data keyed against a URL that would become available without a connection. And as you can see, that's no longer available. The whole Google Gears thing was shut down. But that's because most of the ideas were taken on by the What WG. The offline stuff was reimagined as offline web applications. And therein lies the application cache, the kind of anti-hero of the talk. Now, the application cache is like a candidate from The Apprentice. And I don't know if you guys get the UK version of The Apprentice here. If not, you're probably wondering why I've shown you a photo of a shaved hedgehog of a man who looks like he's suffering from ingrowing spines. This is the kind of the boss man in the UK version of The Apprentice. He used to run Amstrad. It's called Alan Sugar. Now, he's a bit of a douchebag, but I promise you he's way more bearable than the United States equivalent, Donald Trump, whose hair alone looks like a cloud of piss that's become lodged atop a ragged sex doll. But the application cache is more like a candidate from the show, one of these guys. When they're interviewed, they're incredibly confident. They'll turn to the camera, stare it directly in the lens and say, I can turn your offline user experience from sucks ass to success. And it's really easy, just one file, and bosh, it works. But when they're actually given the task, they'll desperately try and take over the whole operation and they'll trample over everyone else just to try and get noticed. The job will get done, in a manner of speaking, but you're left with this loud, horrible business douchebag at the center of it all. And as developers, we have to be very careful to hide that douchebaggery from the end user. And we're going to look at how you might do that. Now, for the sake of this talk, how you use application cache, it kind of depends on the kind of site you're building. We're going to look at 2 extremes, sites that tend towards doing stuff with content, and sites that tend towards getting content, finding content. In terms of get stuff sites, talking about things like Wikipedia, travel sites, YouTube, Twitter, these are sites with loads and loads of content. And as the user, you will search for that content, and when you found the content, you'll look at it. The heavy lifting tends to be done on the server, and they tend to have a lot of URLs that should be meaningful, but they're not always. Do stuff sites, we're talking about things like Google Docs, linters and validators, games, online IDEs. These sites offer quite a small amount of content themselves, relatively, but you can do a lot with that content, or you can use them to create your own content. The heavy lifting on these sites tends to be done on the client, and they tend to have sort of a few URLs compared to the other sites. This is the main case that application cache was designed for. However, the application spec, cache spec, is a bit like an onion. Peeling through it can reduce a grown developer to tears, and that's what happened to me. So how will we go about offlining a do stuff site? Now, I realize that I've just taken the word offline and verbified it. In fact, I just took the word verb and verbified that as well. But there isn't really a good verb for saying to make a site work offline. And I'm told it's best to explain things using your own words. And these words aren't even in the dictionary, so I say I get double points. With that in mind, we're going to look at offlinerizing SpriteCow.com. So I don't know if you've seen SpriteCow before. It's the only useful thing I ever made. Basically, you throw it a CSS sprite, you'll click a part of it, and if I hit it right, it'll give me the CSS for that. So, pretty simple. It's all one HTML page. All of the processing is done client-side. This is a live demo running inside Chrome, by the way. As you might expect, if I were to cut the connection to the site and refresh the page, it all fails. And that's a shame, because it would be nice to be able to use SpriteCow on the plane or on the train where connectivity is not so certain. So let's fix that. To make a site work offline, we take the HTML element and we point it at a manifest like this. Now, thankfully, the manifest file isn't XML. We got over that whole thing. Unfortunately, it's not JSON either. It's this custom baked format. It looks like this. It starts with cache manifest in capital letters, which is it's not a great start. Caps lock is the sword of the douchebag. Screaming your own name at the start. But after that, just simply list all of the files that your site needs. Your JS, your CSS, images, fonts, icons, stuff like that. Theoretically, you can put any kind of file in here that you would normally need a network connection for, but support can get a little bit wobbly. If you're going to try and, for instance, if you put a video file in there, I know for a fact that it doesn't play on the iPhone, for instance. But with things like JavaScript, CSS, you've just got standard page assets. It works fine. All these URLs are relative to the manifest file, not the page, which is useful. But you can also include files from completely different domains like this. The rule is you can't cross the schemes. If your page is HTTPS, then you can only be including HTTPS URLs and vice versa. You'll notice that the HTML page itself isn't listed here, and that's because any page that points at a manifest implicitly becomes part of the cache. Oh, and you need to make sure you serve it with this content type, text/cache manifest. That's going to be dropped from the spec, but all the current implementations require it, so you need that for the moment. So with that small, simple change, I'll be able to turn the connection off and refresh the page, and it works just as if the user had a connection. So that was dead simple. And the browser support for that is pretty good. The desktop browsers have supported it for a while, as you can see, as far back as version 4 of Chrome. On mobile, the support is pretty good, and it's getting better. We've got iOS, Android. The BlackBerry's default browser support started a long time ago, and it's getting better. Unfortunately, there's no support in Internet Explorer, and that means no support on Windows Mobile either. Although the latest previews of IE10, they have it in, so we can kind of assume that when IE10 fully ships, that will have app cache support as well. All the browsers let you use app cache transparently, with the exception of Firefox, and Firefox will show a dialog where the user has to give permission, and that's true for the mobile version as well. So with all that, it can seem at first like this was a very easy piece of progressive enhancement that we added to our site. But watch this. Can you guys see that? Let's make it a bit bigger. So I'm going to check the heading there. I'm going to change it to something else. I find Web Rebels really difficult to say, so from now on I'm just going to call it Webbles. It's easier. Okay, so we've changed the heading there. But we're not getting that change through onto the page. And this is the first bit of evidence I'm going to submit that the application cache is douchebag. The application cache is completely taken over. Let's try and sum up what's happened so far. The first time you look at a page, it's loaded normally, as you might expect. And if we get an HTML page and that page has a manifest, then the manifest is downloaded. Then all the files listed in the manifest, they're downloaded as well. And if they all download successfully, then it forms part of the cache. If any file 404s, 500, something like that, then the cache won't work. The cache won't settle. I've seen this described as a gotcha, but no, this is actually a really, really good thing. This is what makes it better than the cache we have already, because that means that you can rely on your cache being entirely populated or not there at all. You never get a kind of in-between state. Subsequent requests might go differently. So if a page is cached, it will be served from the cache. Otherwise, things happen, as we've seen already. A lot of blog posts and speakers on the subject, they make the assumption that the cached version is only served if you're offline, but that's not the case. If there is a cached version, it will always be served from the cache. But when you request a cache page, the application cache takes over immediately. But the benefit of this is the browser doesn't have to waste time deciding if you're offline or not. I mean, what does offline mean? It means maybe you've not got a cable connected to your computer. The router that you're connected to doesn't have an internet connection. The site you're trying to connect to is down, or there's a DNS problem or a proxy problem. Detecting that all takes time. So this, always serving a cached version, makes it always fast. You don't have to wait for that. Although the page always comes from the cache, in the background it will check to see if there's any updates to the manifest file. But if it is checking for updates, what's happening here? Why are we still not getting our heading? So another piece of douchebaggery. The application cache has its own system of cache validation. You see, the application cache won't update the files within it unless the manifest file itself has changed in some way. And by change, I mean any change, anything that makes it not byte identical. If we take the manifest we were looking at before, you'll notice a lot of these URLs have version numbers. You can see that on the CSS file v1. And because they're far future cache, changing them involves changing the URLs, so they become version 2. And that's also a change to the manifest file, so everything just kind of works as we might expect. And that's fine if we're changing the CSS or the JavaScript or whatever, but we're changing the HTML. And that's not listed here. And even if it was listed here, it can't change the URL easily because, we'd be breaking people's bookmarks, etc. Common practice to get around this is to add a comment onto the manifest file. Like this, comments begin with a hash symbol in manifest, but even though it's a comment, this counts as a change to the manifest file itself. So people tend to put like a dummy version number. I'm just using a single digit. You might want to use some kind of clever build system that does something similar to e-tags of all the files that are in there. This is the biggest ball ache when developing app cache sites. You make changes to your files and you have to remember to change this as well. And you can't just generate a random number during development. The reason for this is when a manifest file is updated, it downloads the manifest, it downloads all the files in the manifest, and then at the very end, it downloads the manifest again. And if the manifest file has changed mid-update, the cache process will fail. And it's kind of a clever thing. The reason for this is if the manifest has changed halfway through, you might have got the first 3 files from the first version and then the last 3 files from the second version. So it kind of cleverly thinks, okay, this was in some state of transition when I downloaded it, so it will try again later on. The app cache's byte-for-byte manifest check is additional to normal caching, or at least it is in most user agents. It's not a replacement for normal browser caching, and you shouldn't treat it as one. You shouldn't use it as some kind of drop-in performance enhancement. I know it's something that Steve Souders used to suggest, but he's decided it's not, and it really shouldn't be. This is what catches people out when they start playing around with app cache. They'll make a change to a file, they'll change the manifest, but they still don't see a change on the page. And that's because they haven't set up proper caching headers. HTTP obviously has versatile cache instructions. At a basic level, we can say, don't cache this file, or check back with the server, or assume this copy is good for a year. But without one of these, app cache will go to the networking layer and say, hey, update this file. And the networking layer goes, but it doesn't have any caching instructions. How should I update it? Oh yeah, however the fuck I want. And it'll go, maybe this is probably okay. Because the networking layer tries to do as little effort as possible. So sometimes it'll just pass the file back without even making a network connection. The app cache will unwittingly update itself with a stale version from the normal browser cache, and it won't tell you it's done this. This kind of copying is great when it's under control because you're saving HTTP connections and that's time for the end user. But out of control copying has awful results. Out of control copying took Street Fighter and turned it into Street Fighter the movie, and then turned that into Street Fighter the movie the game. This actually happened. I assume at this point someone had to step in and reboot Hollywood and reboot the games industry before they just got into a complete loop. In terms of your manifest, you'll want to far future cache anything that can easily change URL and changes infrequently. It's your CSS, your JavaScript. For anything that changes maybe more frequently or can't change URL, you want to serve that with no cache or must revalidate. But just make sure you change a comment in the manifest file when you need to pick up an update. Now, following that advice, you might think that you could do the same with the manifest file itself. Like say, hi, I'm going to put a version number in my manifest file and far future cache it, save those HTTP connections. And then when I do need to make a change, like on Tuesday, I'll bump the version number and that will have the new manifest. You must never, ever do this. The application cache will really punish you for doing this. The problem here is, where does the browser find out about the new manifest file? It finds out about it from the new HTML file. But where does it find out about the new HTML file? Well, from the new manifest. You've created this circular dependency that you can never satisfy. And I did this with SpriteCow, and it was about 30 minutes before I realized what I'd done and reverted the change. Now, according to Google Analytics, 20 people had visited the site in that time. Those 20 users will never get an update to the site ever again. They now live the life of, BlackBerry fans. Everyone else is getting shiny new stuff, but they're getting the same old shit again and again and again. So before we move on, why do we have to change why do we have this change of the manifest to trigger an update? Why is that in place? Well, I think it's a stupid reason, but here it is. Imagine you had a manifest like this, and you've got 50 files in there, lots of pages, and their URLs can't change. Now, updating this manifest is 50 HTTP requests. Well, 52 if you count the manifest at either side. And that's too much overhead to do on each page. The text changing trick just simply makes it your problem rather than the specs problem. It's really sweeping the problem under the carpet. But let's prove a point. Let's get the heading changed here. So if we go into the manifest file, and I'm going to add v2. Does that work? Yeah. So just to prove a point, refresh, no change. Refresh again, and it works. Excellent. But we saw something important there. It took us 2 refreshes to see the change to the page. And unfortunately, that's by design. As we've already seen, the cached version is used if there is one in the cache, and then the update happens transparently in the background. But that means by the time the user gets the update, they're already looking at the old version from the cache, and they'll only get the new version next time they begin the connection. There's a JavaScript event you can use in this situation to try and work with it, and it's called update ready, and it fires on the application cache object. Now, this fires when there's been a change to the manifest. The manifest is successfully downloaded, and all of the files within there have been successfully downloaded. But what can you do at this point? You can call swap cache, and that starts using the new cached files immediately for subsequent requests. But that's useless because the horse is already bolted by this point. The user's already looking at the old version of the page. This is a really niche bit of API that there are very few use cases for, and it can seem really confusing to people who just read it. It kind of sounds like it might swap stuff that's already been loaded, but that's not what it does. You can trigger a reload, but that's not such a great user experience. I mean, imagine you were writing an email on Gmail and it just refreshed on you. That's not a great thing. A compromise is just to show a message to the user, something within your app. You might have seen this on the Web Rebel site itself, because it uses app cache and it shows a message like this when there's an update. Another compromise is just to not really care about it, and that's what I did with SpriteCow. Okay, so people might be on the old version for one view, not a big deal. Obviously a much bigger deal for Webbles, the Webbles site, because it might be showing incorrect times. There might have been an update to the schedule. So are we done? Yes. Well, almost. Things are looking like they're working, but a nasty little bug has crept in, and you'll only see it if you were looking at Web Inspector or Firebug or something. The page analytics have stopped working. So what's going on here? Well, here's a more visual example. So here's a page with a couple of kittens. It uses a manifest, but only the CSS file is cached, not the images themselves. So even though we have a connection, if I refresh the page, the images fail. This is a big piece of douchebaggery. The application cache doesn't like things that aren't in the application cache. The first time we saw the page, it wasn't cached, because that was the first time we looked at it. But then the cache was created in the background, we refresh the page, we get the version from the cache, and things start breaking. Afraid we have to go back to the big diagram to explain what's going on here. I'm afraid we've missed some detail from the top. So whenever the browser makes a GET request, it looks to see if that URL is associated in some way with a manifest file. And if it is, then it uses it. And things go on as we've seen. If there's no manifest file associated, then the request just happens normally. Now, that kind of sounds like what we've been saying already, but it's a more complicated way, but here's the difference. Every request that is triggered inside a cached page, your CSS, your JavaScript, the images from before, they go back through the process again, but it doesn't reselect a manifest. It'll use the same manifest of the host page. And if that image is cached, then it will come from the cache and everything's fine. But if that image isn't cached, then the connection will fail. It's no coincidence that this part of the specification is in section 6.6.6. This is the specification of the beast. And that's what's happening here. That's why these images aren't loading. But we can fix it using the networking section of the manifest. And here we can list individual URLs. Then, as you can see, the images started working again. Or we can just put a star, and that will make all the connections start working. So what's happening here is if the image isn't cached, but it is specifically listed in network, it's requested normally. If not, but there's a star in network, then it's requested normally regardless of URL. Otherwise, it fails. Files listed in the network section, they're not cached. They won't work offline, but they will work online. So you need to make sure that your online-only assets, such as your analytics scripts and such like, you need to make sure they're covered in the network section by one of those methods. Well, that's it really. We've covered the simple example. And it was at this point that I wanted to lock myself in the bathroom until the internet had gone away. In the end, cubicle at my previous job, where it can't get me. But this is Webbles. We're not afraid of peeling the app cache onion a little bit further. Reference sites have completely different requirements in terms of app cache, and I'm going to use m.lanyard.com as an example because it's something we built and where I found out about most of these problems from. With m.lanyard, you can look up future conferences, get information about events you're tracking and attending, and you can look up information about specific events, the schedule and stuff. So making this work offline would be great because you can look out on the plane or whatever, find out what the schedule is. But there's far too much data to offline-ificate everything, far too much. But then the user's only interested in a very small subset of the data the site has to offer. How can we make this work offline? Mark Pilgrim, in Dive into HTML5, he had a decent section on the application cache and offered up a solution to offline-arize Wikipedia. That might be useful to us. And it worked by having every page on Wikipedia pointing at the manifest. And that manifest just covered the CSS, the JavaScript images, whatever. But because pages pointing at a manifest are implicitly cached, as you get lost in the Wikipedia labyrinth, more and more of the site is becoming available to you offline. Very, very simple solution, but it's also completely dreadful because there is no indication of which pages are available offline. The user can't tell what's going to happen when they don't have a connection. And there's no API. It's one of the main things. I don't understand why we have swap cache with this really niche usage, but we don't have a method just to say, give me a list of all the cached URLs. And it's near impossible to manage updates as well. These cached pages, as they build up, they're only going to update when we change the manifest. But when do we change the manifest? Like every time a page on Wikipedia is changed? That's going to be far too often. And when those updates do happen, and they're going to happen all the time, they're going to be really heavy. I mean, say you've looked at 100 pages on Wikipedia. Now, every time the manifest file changes, which is going to be all the time, those 100 pages are going to have to be re-downloaded, and they're not cacheable, so that's 100 HTTP connections. And think about how many Wikipedia pages you've looked at. It's probably more than 100, right? And that number's only going to grow and grow and grow. And because we don't have a way of expiring pages out of the cache, it will eventually hit the limit, and the browser will explode. There's nothing we can do about it. Ideally, we want to be showing up-to-date content to the user while they're online, avoid showing them stale data, and control which content gets cached and defer some of that control to the user, probably in the way of like a save offline or read later button, and indicate which content is available to the user when they're offline, make them confident So when they're on a plane, they know exactly what they're going to be able to access and what they're not going to be able to access. And we want to set this up with a single view to any page on the site. So even a deep link, that should be setting up the caching in the background. And we want to use the JavaScript and application cache as enhancements. It really annoys me that people think JavaScript reliance is okay on mobile. If you can do it simply without JavaScript, then it should be done without JavaScript and then enhance with JavaScript. We learned that lesson the hard way, right, on desktop, but we seem to have forgotten it on mobile. Look at the Twitter site on both desktop and mobile. Its reliance on JavaScript is completely unnecessary, and it's slow and clunky as a result. And I'm assured that it's terrible to maintain as well, and they're really struggling with the URLs at the moment. M.Lanyard works without JavaScript, and as a result, we've been able to support a ton of platforms really, really easily. This is the BlackBerry Bold 9000, right? This is 4 years old, but it acts older. It's back from the days when BlackBerry made their own browser, but it was very popular and still haunts people's pockets, especially in big businesses. Its HTML rendering is on par with about Internet Explorer 8, but its JavaScript engine is just like a random error generator. It's completely terrible. But we were able to support this device pretty easily, just by having a simple feature test in the head of the page. Just say, oh, is application cache there? Is JSON there? Is local storage there? But we did something very dirty with that data. Now, I warn you, if you're easily offended, you might want to look away. Whenever we loaded a script, we'd wrap it in this. So what we're doing here is, if there isn't basic support for those things, we'll document.write an HTML comment. For all browsers such as BlackBerry, that comment would appear at the end of the script element and hide the external script from the browser. So that not only prevented it from executing the JavaScript, but also prevented it from downloading and parsing it. And it's a horrible, horrible hack, but it was extremely effective. This is the same phone loading the same page in the same way. The one on your right uses the horrible hack. The one on your left uses plain old feature detection. And if we set them off at the same time, we can see that the hacky version, that loads in first. That's fine. The user can use the page. The other version still hasn't loaded. The user's getting very annoyed. And finally it loads. And this is just a result of that hack. These old devices are really slow at parsing JavaScript, that it adds about 7 seconds per page load. Like per page load, you can't get around this with caching because it's parsing. It can come from the cache, but it'll still have to parse all that JavaScript. And doing this was only possible. We were only able to tackle this because we didn't rely on JavaScript. We built the site using progressive enhancement. Unfortunately, application cache makes this a pain in the arse. In fact, it makes all of our requirements a pain in the arse. So when I was a kid, we had a sandbox in the garden. I'd go there to play and build stuff. It was a really good creative outlet for me. However, the family cats, they also use the sandbox for a completely different kind of outlet. It turns out you can't make sandcastles out of cat shit, although I tried. But fast forward over 20 years, and here I am again. Someone's crapping in my sandbox, but this time it's the application cache. Putting a manifest attribute on an HTML element means the application cache moves in and takes over the whole operation. So to get around that, to solve this, we want to take the application cache and pop him in a box, where he can be Schrodinger's douchebag until we care whether he's dead or alive. To do this, we're going to use the manifest file on one page only, offline stuff.html. We're going to make sure the browser knows about this page from all of the others by hiding it as like a secret iframe on all the other pages. This could be a completely invisible one. Now, the manifest includes all of the usual stuff that we've seen so far, but also another rule, fallback. Now, the fallback rule has 2 parts to it, a URL prefix and then a file to cache and maybe serve later. Now, the way this works, if a file isn't specifically listed in the network section, but the URL matches one of the fallback prefixes, and it will try and match against the longest prefix it can find. If there is a match, that file will be requested normally. And if that file just downloads okay, then it will just use it as if the application cache wasn't there. If the request fails, then it will get the other URL that you gave it. It will get that from the cache. And that gives us a really nice fallback system. So that means we can give the user a different experience if they're online to when they're offline. So as you can see, there's one page here, online page. And if I cut the connection and refresh the page, Right, we get a completely different page. And the URL stays the same as well. This is a kind of like a rewrite rather than a redirect. And that comes in really useful later on. So unfortunately, using this gets us into a few browser troubles. Well, one browser trouble. By using fallback, we wave goodbye to Opera support. And that's a shame because they've had that bug for a while now. We have code like this on Lanyard, you know, if Opera don't rely on application cache. And it's the only browser sniffing we have, and I'm really looking forward to getting rid of that. I think it's going to be fixed in Opera 12, so that's good news. So we're using the manifest for static content only, and that's great. All users have the same manifest because we didn't want to think about the idea of serving custom manifests for users. So where do we store user-specific data? We're going to use local storage for that because it's extremely simple. And I've thrown together a quick demo. So from this page, you can see, well, I hope you can see, that I have two test articles. One of my test articles is bigger than the other test article. But as you can see, both pages have this Save for Offline Access button. I'm going to click that. So what's happening when I click that? When people click that button, it's going to get the HTML of the page and look at the URL path. And then it's going to save that HTML into local storage using the URL path as a key. And it's going to update an index file as well, so we can quickly look at which pages we have cached. So now if I disable the connection and refresh the page, it just appears to work to the user, but it's actually going to a different page in the background. And what happens here is it looks at the URL path, because remember the URL stays the same even though it's loading a different page, and it looks in local storage for content for that URL. And if it exists, it repopulates the page. So it's a really simple way of having full control over the cache. This is a simplification. You'll want to catch a case where you might not have any data for that URL. You want to show the equivalent of a 404 page, or maybe the index hasn't been created yet. But the index is extremely useful because it means we can now, on our index page, show, yeah, this article is available offline. Just a quick JavaScript function can just go into local storage and query that. This is the same mechanism as we use on m.lanyard.com with a few differences. We store JSON rather than HTML. And this is a more efficient use of local storage. Each event has 4 JSON files, one for the event, one for the schedule, one for the attendees, one for the speakers, and that allows them to update independently because the attendee list tends to change more frequently than the schedule, for instance. And when you hit a page about a conference, there's version numbers and data attributes, and that's how it decides whether the data that's coming back from the server is newer than the version you have in local storage. And all of this is rendered into mustache templates. We share templates between the server and the clients, so we're not repeating that stuff. And it's the server that's responsible for remembering which data is cached. We do that in the way of track and attend buttons. So that means that if you format your device, or the cache just gets lost, or you change phone or whatever, one visit to m.lanyard.com when you're logged in, and we can repopulate the cache really quickly. And we can expire old data as well, and that's really easy to do. As soon as a conference goes into the past by a few days, we get rid of it. We decide you're not going to. The m.lanyard is mainly for current and future conferences. So once it goes into the past, we remove it from the cache. We also have more error correction as well, because every time you read or write from local storage, that is something that can fail. So you always want to wrap that in a try-catch block and do something sensible if it fails. Is the system perfect? No, not really. It introduced a few more problems. On Lanyard, when you click a link, the URL is fetched using XHR. And we update the URL using pushDate. And we get the minor speed boost from this because we don't have to reparse some JavaScript. But it's mainly about giving more of an app feel, and we can use our sort of custom loading message or whatever. Unfortunately, a few devices have problems with cached XHR. jQuery and similar libraries, you'll recognize this, .done and .fail, especially in the new deferred model. They determine XHR success based on the status code. Unfortunately, some devices return a status code of 0 if it's come from the cache. We're talking things like iOS 3, but who cares about that? But also the BlackBerry Playbook, the latest version, and the Android 3 and 4 browser. The stock Android 2 browser doesn't have this problem, but the stock Android 2 browser also has pushDate, but 3 and 4 don't. Thank you very much, Android, and your regressions across the browser. But that's what we're seeing here. We fix this by taking the response, whatever it is, whether it succeeded or whether it failed. And if it was aborted by the user, in which case the status text becomes abort, well, we just exit straight away. But then if there's a response text property on the object, that smells like an error, because usually when a connection succeeds in jQuery, it just gives you the string data from the result. But if it's looking like an XHR object, then something might have gone wrong. But if it has a response text and it's populated and the status code is less than 400, then we kind of rescue the text. This is the bug that we're catering for here. Otherwise, we just handle the error as we normally would. But now we've got the response. We've rescued that status 0 case. Okay, this is a browser bug rather than a specification issue, but the specification is not helpful in this case either. It really screws us over with in-page requests. Earlier we found out that if a request is made from a cached page, it will always come from the cache. Unfortunately, the inverse is also true. So if the page is requested normally, then connections triggered by that page, JavaScript, CSS, XHR, they will also be requested normally. Application cache wants no part of it. So if a user requests a page while they're online, but then the train goes into a tunnel or whatever, XHR connections will start failing. New images will fail, even if they're in an application cache. Even if they're covered by a fallback rule, they'll just fail. Lanyrd gets around this by, if one of our XHR connections fails, we just replace window.location with the URL the user requested, and that sends things right back to the top of the diagram, and it will pick up the manifest again. Another drawback to this method is we get problems with error feedback. Now, you might have noticed when I built this part of the diagram before, there is some small print there. The fallback is used if the connection fails, but what constitutes a failure? A failure can be a general networking error, an HTTP response code starting 4 or 5, or a redirect to another domain. And that sounds odd at first. Why is a redirect to another domain considered a failure? It's to try and catch these things, these captive portals. You've wandered into some kind of Wi-Fi zone that's pretending to be free, but it actually wants your credit card details. And it treats that as a failure. But that also means you can't legitimately use server redirects. So if you do a server redirect off of Facebook or Twitter for login, you can't do that with app cache, because it will treat that as a failure and start falling back. Unfortunately, when a fallback page is used, it doesn't tell us why. It could be any one of these things. We're not given that information. And because of that, we can't tell the difference between a mistyped URL or a page the user doesn't have cached, which makes our error messages a little bit vague. There's just nothing in the spec to let us deal with that. But that's it, really. We've covered most of the gotchas of the complicated case, and it's turned what was a very simple diagram into a big, horrible Christmas tree, I think. Where the presents will probably be more like the presents my cats left for me in the sandpit rather than nice presents. I think the point I've been trying to make in the last 40 minutes or so is the application cache is a douchebag. As part of my kind of personal therapy at work, I created a set of post-it notes. There was one for each browser. The theory was, whenever a browser made my day unpleasant, I could just draw a little cock against it, and I kind of was able to calm down. But because of this whole thing, I had to create a separate one for the application cache, and it quickly became what can only be described as riddled with cocks, just in a few hours. But the application cache is extremely useful. It can do stuff that no other feature can, and we need to learn to work with him. But his mere presence on a page will change the behavior of your site. It's not a piece of progressive enhancement. It really wasn't built with that in mind. You need to build your whole site around it, which can be okay with small things such as SpriteCow. That's fine. Otherwise, you need to sandbox it. Use the iframe trick. Make it so the cache is only used when the connection fails. But use local storage for anything. We can use the application cache for static files. Do that only. For anything that's user-specific, use local storage. And that's it, really. It's over. Thank you very much. If you want to email me, that's my email address there. My Twitter is there. I've got demos and tests that I use to come to these conclusions. They're all up on GitHub, so you can have a play around and find particular browsers where something I've said is wrong. That would be great, because then I'll learn more stuff. And the slides will be up later today online, and probably on the Webbles website as well. So thank you very much. Cheers.